In this video I'm going to look at the 6 different types of formulae we use in organic chemistry. So you can see them written up in red there down the side, and I'm going to base everything on one molecule just to keep things simple, and that is butane. So because butane is a member of the alkane family, it has the general formula CnH2n plus 2. So the general formula is the algebraic formula, or the nth term formula for the homologous series. So if we apply the general formula, n is 4, because we've got 4 carbons, we get C4H10, which is actually its molecular formula. And so the molecular formula basically tells us how many of each type of atom are present in the molecule. The empirical formula is the simplest whole number ratio of each type of atom present in the molecule, and so for butane we can get C2H5. So if we move on to structural formula now, so we can actually appreciate more the actual molecule itself with structural formula. So it's given us sort of the minimal detail of the arrangement of the atoms in the molecule. So CH3, there's the CH3 there, CH2, 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 and then CH3 at the end. You can also represent the structural formula like that, and that becomes very important, or very useful I should say, when the carbon chain gets much longer. So we take all the CH2 groups and we put them in a bracket, and we just put the number of them outside. So we've got 2 CH2 groups in this molecule, and so we've got 2 CH2s from the bracket. So displayed formula is kind of a step up from the structural formula, because as well as seeing the arrangement of the atoms in the molecule, we can actually see the bonds that are connecting the atoms together. So we've got single bonds between the carbons and the hydrogens, and the carbons and the carbons. Just to bear in mind here, the bond angle between all of these atoms would be 109.5 degrees, but we tend to draw a displayed formula in the sort of flat 2D arrangement. But you can see from the model that it's actually a tetrahedral arrangement around each of those carbons. And you can see at the bottom there, the final type of formula we use is called the skeletal formula, and basically that just shows the carbon backbone or carbon skeleton of the molecule itself. We take all the hydrogens off, and basically at each sort of kink in the chain is a carbon. So we've got a carbon here. Now if you remember, carbon can form 4 bonds, so there's one of the bonds to the next carbon. So what else is on the end here? There must be 3 hydrogens to make those 4 bonds. This carbon here, we've got a bond, so that's that bond there, isn't it? So a bond here and a bond here, these 2 bonds. So you can put 2 hydrogens on there, 1, 2, 3, 4, 1, 2, and same for that one. And then this is the same as this, so we've got a bond, that's that bond there, to this carbon, and then 3 hydrogens on the end.